right, so quick disclaimer. As probably you guys have heard, our two colleagues, unfortunately, they were not able to come here, which was Hussein and Charlotte. They were sick. So yesterday, me and Lucas, we decided to take a challenge and set up a quick talk, hopefully for you guys, that we want to share with you, something that we experience in our job. So hopefully you'll have some fun and you enjoy what we're going to present to you. Yeah. Moving further, I'm David. I'm a senior principal at Liquid Reply, being in Liquid Reply for the last 5 years.
And I'm Lucas Brüning. I'm a consultant at Liquid Reply and being at Liquid Reply for almost over a year.
That's very good. And what we want to talk to you guys today is about crafting the foundation of sovereign AI platforms. So, simple use case. I think all of you already go into the situation where AI is everywhere. Everyone wants to have an AI solution. So the customer comes, oh, let's do a POC about this, about that. So POCs are easy, right? So we create a model, we create a couple of data sets, we put a chatbot over there, boom, POC is fantastic, it works, customer loves it. When can we deploy it? Can we start tomorrow, immediately? But the problem is, when you work with big corporations, trying to be fast is tricky, because you have then this governance and controlling, where you have to answer questions like, what model are you going to use? What data are you going to put there? What guardrails are in place? So you start to have some difficult questions that you need to be able to answer. And when we start to think about how we're going to tackle all these points as a team, we started to think about we need sovereignty, right? Because if we are sovereign, we have control over our application. And being sovereign is not in the sense of what EU cloud provider I'm choosing or where the data is running, but that's a part of it. But the complete flow is when we are able to control the full life cycle of our application, when we control the models, the infrastructure, the observability, and so forth. Yeah? So in order to be sovereign, there's a key aspect that we taught. So in order to be sovereign, we need to be portable. So we need to be flexible with our workloads. So if we cannot move our workload, then our control is limited. Because yes, we can move, but then we have to go to our source code, change, point to the new provider, whatever they are using. So it requires effort. And the idea that I want to challenge all of you is to start to think how you can be portable if you create with a mindset or with a strategy of exit from day one. So what I mean with that is not that after I do the deployment I want to leave, but if I have the possibility to move my workloads over time, then I have full control of where I want to do and where I want to use and run. Yeah? So that's exactly what I would like to show you today. So we created a modular platform foundation. And as you can see from this architecture, the idea that we try to bring into the table is that we used open source components as OpenWeb UI, FlowWise, LightLLM, etc., so that we are able to create our modular platform, so that we can run what we want, control where we need to run, because we need this flexibility if we want to actually be sovereign. Yeah. In the end, I would like to call then my colleague Lucas to now do you a short demo and go through all the models that I'm showing here in this architecture a bit more in detail that maybe this could be interesting for you, for your company, for your work. So, Lucas, time to shine.
Thank you very much, David. So, I will start with probably the entry point most of you are familiar with. Let's start with a chat interface. So, for our platform, it is just, let's call it, one way to do a front end. In this case, it's an open web UI. You can use any other web UI you like, or you can even use some, let's call it CLI clients like Claude Code, OpenCode, Codex, Pi, and how all of them are named. And this is one of the, one way to show it to you. Quick information about the demo or the architecture itself. All of this is running on the Scaleway cloud provider, and we have a Kubernetes cluster. All of this is running on Kubernetes. And we also have one model which we are hosting on GPU nodes, which are on Scaleway. So here we have our model. It's very, very big, Mistral VLM. We use the models of Mistral AI, so we can show a sovereign approach, which is not coupled or not connected to any US companies in any way. So we use the models of Mistral AI. We can obviously choose a lot of models up here. If you can see here, there are multiple Mistral models, but we would like to showcase how seamless it is to run a local model. It's called Mistral VLM because it's running on the VLM inference engine. So let's just take one of the examples in here, help me study, and you can see, as you would expect, it generates one response, and you can continue chatting with it, you can send it images, you can send it documents, and whatever you like. And this is one way to do the front and the entry point, basically. So this is very nice. But you already saw the models, which I showed you up here, but how they are connected. How does OpenWebUI know which models are available? And this is done via LightLLM. We have LightLLM here. We see here, this is the entry point. We see here our virtual keys, basically. So in LightLLM, we attached an API key we got from the Mistral AI platform. And we attached the key to LightLLM, and LightLLM is capable of creating so-called virtual keys out of it. So basically, you have your main API key, which is connected to LightLLM, and from this main API key, your users, your colleagues, your employees, whoever can create virtual keys. And these virtual keys can be restricted in budget, can be restricted in rate limits, can be restricted with guardrails and permissions, and so on and so forth. LightLLM also offers the consolidation of users into teams and the consolidation of teams into organizations, which you can see here. And so you can attach you can create one user, and one user is able to create API keys. Maybe one user is able to create max budget, and you can even attach these API keys to teams, and you can attach these API keys to organizations or individual users and so on. And all of them, and you have to control about all of them. So you can rotate keys, you can delete virtual keys without touching your main Mistral or your main LLM provider API key. Another thing I would like to show you in LightLLM are the security settings you can do. These are done with guardrails in LightLLM. So basically, LightLLM is our central point, let's call it, where every LLM request is inserted. And then we can do some filtering, maybe some guardrailing. Here we have some example guardrails. And we have some guardrails which are capable of filtering personally identifiable information. So some kind of Visa card numbers, MasterCard numbers, IP addresses, and so on and so forth. And we can say, okay, every request which goes through LightLLM, our central entry point, please mask all IPv6 addresses you see in the request. So the requests are not actually getting sent to the LLM model. They are filtered in LightLLM beforehand and masked and censored. You can also completely block requests if you like to, but in this case, we used the masking capability to not disrupt any workloads, because this can be quite disruptive if you disrupt your workloads. And you can see here, if I go to the models and endpoints, you basically see down here, all the models are just showed to you in the Open Web UI. So you see here the multiple Mistral models, the 5 Mistral models down there, which are directly connected via the API on Mistral AI. And we have the VLM model here. So this is, as I said, locally or served via our GPU nodes, which are running on Scaleway, fully sovereign, without needing any connections outside. This is the part, the light LLM part. So now we have light LLM, we have our central gateway, AI gateway, where we can talk to LLMs, and we have some kind of front end, let's call it, Open Web UI. And what about observability? So we have like the models, but we don't know who uses which models, how much do they cost, and so on. This is where LangFuse comes into play. And in LangFuse, everything starts at home. So basically, you can see here a lot of dashboards. So you can see the, let's call it the key metrics, like traces, how many requests have been sent to Light LLM, or in general. You can see which costs are done by the models, or your total cost. And then you have like some neat graphs where you can see the traces over time and the cost over time. Obviously, there are many, many more charts you can do. Here you can even build your own charts if you like, but these are the default charts, and they are very, very strong already, and they give you some kind of, they give a visibility on what is exactly happening on your AI platform and who's using how much of the AI platform. Another thing, which is quite, let's say, in my opinion, very powerful, is the tracing section. So here you can basically see every request which got sent to Light LLM, and there you can see information like, okay, what was the input prompt? What was the actual output of the LLM model? What was the latency? How many tokens did it use? How many did it cost? What was the input cost? What was the output cost? Have there been any tags? In which environment did it happen, etc.? So this is all you can see here for every single request in your AI platform. These are although these information are very detailed already, you can even go deeper, a layer deeper. Let's maybe go into this one. And there you basically are inside the trace. And in the trace, you see much more information. You see, as you can see here, you can see, okay, what was the original user prompt? And then you can see the assistant answer. This is quite simple. This is quite a simple workflow. And obviously, the chat flow or the chat history can be much, much longer. There can be a user message, an assistant message. There can also be system messages in here, etc. It can be way, way more complex, and you will still keep your overview of what happened in one trace. One very neat feature, in my opinion, of LangFuse is the agent graph you can see here. This is a pretty linear and not a really complex. Oops, I'm sorry. Wait a second. So basically, this is my software for taking a break, because sitting is not very healthy. It's not very healthy. So this is basically my breaking software, which tells me when I do a break. That's why it's there. So, but I don't need a break right now. I'm fully energetic.
I think they are aware a lot of things could go wrong.
No worries, no worries.
This is a ad hoc call. Yeah.
Let's talk about the agent graph. And as you can see, it's quite simple, right? So it's pretty linear because we just sent one request, and then we got a response, pretty linear. But let's think about an agentic workflow, a multi-agent workflow, for example. You send one request to an agent, and the agent spawns sub-agents, for example. The sub-agents are maybe spawning even more sub-agents, and the sub-agents are calling tools or MCP servers, retrieving data from data sources, and so on and so forth. It can be very complex, and I think it's a very, very good way to see this in a graph structure like this, and then you are able to also click on the separate little bulbs in here which are showing basically similar information because it's very simple in this case. But in a more complex setup, you would see, okay, what prompt did the agent use for its sub-agents? What was the input for the tools? What was the output for the tools? Were there any errors? Now, the errors are quite important because the agent can answer you even if the tool had an error. So maybe it tells you in the best case, yeah, there was an error, or maybe the agent hallucinates some stuff. They can be very, very dangerous indeed, and very, very, yeah. You need to search a lot if you don't have some kind of overview like this. This is the observability path. Obviously, LangFuse is a lot more capable of just doing observability, as you can see in the sidebar maybe. And yeah, but we will not cover this in this demonstration, but keep in mind LangFuse is a lot more capable than that. And then let's come to our last use case. I think most of you are already aware what RAG is. And we have basically a demo where we have some kind of company wiki. And I think every one of you has a company wiki as well. And I think, especially if you think back when you started at your company, it's maybe quite hard to retrieve information out of it. And here we have a fictional company which has multiple entries in their wiki. And every wiki page is basically a separate markdown file in this data source. The dataset is not really important for us because we can just ask an AI agent or do some kind of semantic search to retrieve data for us. So if we go on Ragflow to the search endpoint, we have some search app, and then we have a need search bar. So basically what you're doing here is like a Google search across your company wiki. So for example, you can just say, okay, I need to do a business trip next week. What is the
budget?
What is the budget of or the budget for booking hotels? So let's send it up, and then we wait for a second, and then we get results. So here, as you can see, there's not, these are basically the snippets out of the demonstration, or out of the data sources, out of the markdown files we set as the data source. And here you can see, okay, we have a table right here, we have additional information, and we can even see the source where our semantic search retrieved the data. And this works with another queries as well. And this is a very, very fast way to retrieve information about your company. If you want to very, very fast maybe retrieve documentation or policies and so on. This is basically the semantic search way of doing it. As you can see, there is not really a chat component to it, but Ragflow obviously has a way to chat with your documents via the chat button or the chat header. And here you can see I already did some chats, so I will just reuse them. And here you can see I basically told it the same prompt. And then you can ask it in natural language, and then the AI, the LLM, responds with natural language as well and says, yeah, okay, we have this and this bad budget, and then you can basically, it gives basically back the source as well. Which is, again, which helps retrieving data very fast and minimizes the costs or the time you need to look up data in your data source. This obviously works with multiple other data sources other than markdown files, but for simplicity, we just choose markdown files in here. And this is basically the key points of our platform I wanted to show you. And if you maybe want to get a bit deep dive into the platform, maybe talk a bit more in detail about it, we have a booth. We are at the Liquid Reply booth. You can find David and me in there and my wonderful other colleagues who very, very intensely built this platform with us. And we can talk about that in there. We're next to the Barcelona stage, right?
Yes, we are next to the Barcelona stage. So if you want to have a quick chat, if you want to know more, feel free to go there, chat with us, with our colleagues. So glad to network and to connect with you guys.
Yes.
I hope you enjoyed our talk. I hope you had some fun. If there are questions, please feel free to ask. David, thank you. Very good. Thank you very much, everyone.
Thank you very much.
There's one. Okay, sorry.
So you showed in one of the last steps exactly this documentation. How do you ensure that this is always up to date? So what is the process behind this that ensures that the source of truth is always up to standard and that it's also hopefully no additional overhead to the people that are bringing it up to date?
So
yeah, go ahead.
Okay.
You
in this case, we just set up a static data source in there. As you can see, maybe I can go to the data set part again. And there we have it's really static markdown files. And in this case, you're right. We don't have an automatic way to have a separate wiki which you can access separately. And this in sync, there's no way to do it in here in this case. But you can connect data sources to it. You can connect a Git repository to it, or your Jira tickets, or your Confluence wiki, and so on and so forth. And then the sync is already done. Or if you are maybe thinking a bit outside of the box, going a bit more into general reg, how reg works is basically you have a vector database, which is created via an which is populated via an ingestion pipeline. And then there are also automatic ways to see if there are changes in your documentation, for example. And then if there are changes, these changes are automatically reflected in your vector database, and then this vector database is used for retrieval like we did it in here. So there are definitely ways to keep this in sync. This is a solved problem, basically.
Hi.
Hi.
Thanks for the talk. I have a question around the anonymization capabilities of LightLM. You showed it to be able to mask PAI data or filter for specific data.
Yes.
And so this is a very egoistic question, I guess, but I'm often working with sensitive data, so special category data according to GDPR. And usually I shouldn't be able to see the kind of data that's in the prompt. But then I also miss out on understanding what the user's doing. I'd love to have a way to anonymize or carve out that specialized sensitive data. What's your experience?
We can show you a use case. Maybe we use the IPv.
We can show you the use case in there. So basically, what you can do, you can obviously build your own guardrails. LightLM is quite flexible regarding that. So basically, you can set your own guardrails, which do your custom logic, and maybe you can say, you do not eradicate it, which does it like this. Let me show you in the example.
Maybe you noticed that in the LightLM, there was the guardrails, and then there was what information you need to, hid, anonymize. And here is now, you see the example that's happening, so he's asking just for this demo purposes, what is this IP, and he already is retrieving you, like the negative. Maybe we can show then...
We can show this also in
exactly.
How the real request looks like. This is how the front end basically looks like.
Yeah, this is how your data is then protected.
So here you can see...
It's redacted. You will not see it in the log files.
Yes, and you can actually configure this placeholder. Now you can see here, it's actually an IPv4 which gets censored in this case. Obviously, you can do some anonymization techniques where you can, or pseudonymization techniques, where you can maybe send another IP or whatever fits your use case. But the context is preserved in this case. So it's not just stripped down, stripped away. It's preserved in this case.
Can I ask a follow-up question?
Yeah, sure.
Please.
And how do you handle the non-determinism of this?
Can you repeat?
Can you repeat what you said? Sorry.
How do you handle the non-determinism of this? So what I'm trying to say is, how do you handle that? I can't always trust that this is actually being redacted.
That's a good question. So, what you can do in this case, this is a quite, as you said, this is a quite deterministic approach. So in this case, I think LightLM is working with pattern matching and regex and so on. What you can do is obviously do a more flexible approach where you put maybe another locally hosted AI model in front of it, or doing, as I said, custom logic. It doesn't have to be an LLM. So you do some, you put some AI model in front of it, and then you have a better cover in this case. And maybe what you should do as well, if this is quite critical, maybe you should put multiple guardrails or multiple ways of analyzing and maybe filtering the data. But in this case, depending on your use case and your prompts, obviously, it is quite safe, in this case. But obviously, the use case matters in this case,
Cool. Thanks a lot.
You're welcome.
Any further questions?
I think
there's
back
one
there.
over there.
Hi.
Hi.
Hello.
Is there also a possibility to use a library for the redacted keywords, something like this?
There is a possibility, So as I said, LightLM is quite, you don't have to use LightLM in this case, but LightLM it fits our use case and our demo. So LightLM is quite flexible in this case. You can do some custom Python scripting, for example, and maybe, do some NLP in there and so on and so forth. So it is basically just, let's call it language and natural language analysis you can do in there. So there are special libraries to do that, and there are even special models which are created by the AI providers for exactly this purpose. So it's pretty flexible, as I said, and there are also libraries to do that, yes. Not only in Python, but for multiple programming languages, but LightLM is based on Python, and you can extend it via Python scripting.
Thank you.
You're welcome.
More questions.
One more question.
There's one more question here. I don't know, we are okay with time? I hope so.
Hi, I'm Ivan. I have a question which probably is unsolved as of today. I'm curious if this framework provides any way to track the quality of the responses, even if it's just thumbs up, thumbs down.
Yes.
How do I know if it hallucinates?
This is actually one of the capabilities of LangFuse
Yes.
I didn't talk about, but you can maybe see here on the sidebar, there are scores, LM as a judge, human annotations, and data sets. So what LangFuse makes you able is basically you can create data sets. You maybe can create data sets of existing traces. For example, here we have a handy Add to Dataset button. And then we can also collect feedback via some thumbs up or thumbs down mechanism on the chat UI on your front end. And LangFuse has an API for that, where you can say, okay, this response was good, this response was bad. And then you can do evaluations based on that. You can create scorings based on that, and you can even do LLM as a judge evaluation on that. So LangFuse has this whole quality assurance and quality assurance part built in, but we did not show it in this demonstration right now, because for us, it's only right now, this is the current situation, purposing for the observability stack. But LangFuse is capable of doing that.
Yeah, maybe to add that LangFuse is built for prompt engineering, context engineering originally. That's why it comes with I need to trace and see everything. And then they found out, oh wait, it's actually quite good in make the observability part too. So that's why it covers both.
More questions? Then thank you so much.
Thank you so much.
And